This is the Lesson 6 video notes on exponents. You guys are now familiar with the vocabulary. When we talk about the words expanded notation and exponential notation, remember this is nothing more than multiplication. It's still mash. Again, the only difference is we're adding this extra thing with the a in mash, which says add the exponents. Let's take a look at example 3. We're going to start by bracketing like we always do. You guys know the rules, and this is starting to get easy for you. Okay, let's start with bracket number 1. One person in each house, so this is a mash problem. Alright, so let's take a look. Negative signs, 2, so it's going to be positive. You guys know the routine. I'm always putting this invisible plus, but you know you don't have to. Then we do the numbers next. 7 times 2, 14. And this is the part where I want to emphasize that it's nothing more than mash. Throw in the peas and the carrots. This is just like having a lot of butter. You've got this x over here. You've got this x squared over here. And you've got this x over here. Remember those pads of butter in the diner? That's basically what you're looking at. A lot of it. Next bracket, 2 in the house. So it's a distribute problem. We are distributing a negative 3. And here we go. So one negative sign makes it negative. Mash the numbers. 3 times 3 is 9. And again, we're going to chuck in the peas and the carrots. Or we can just say a lot of butter. Next arrow. 2 negatives makes it a positive. 3 times 4, 12. Now this is where we have to do this x and then this x and y squared get chucked into the pile. This is nothing more than our mash rules. Signs in your head, numbers in the calculator or your head, throw in all the letters. And last but not least, we have a mash problem because there's only one in each house. 2 negative signs makes the whole thing positive. Mashing the numbers, 5 times 2 times 2 hopefully gives us 20. And then again, we're going to throw in all of the peas and the carrots, etc. So I've got a y squared from here. I've got an x to the third from there. And I've got a y to the third from there. Now, that's expanded. And you can imagine that this is something we would not want to write all the time. So the guy who created exponents, thank goodness, allowed us to be lazy. So we're going to take all these x's and put them together. So I've got 14, and you guys have figured out by now this is really an invisible 1. And over here is an invisible 1. So if we add those exponents, we're simply going to get x to the 4th power. Let's go to the next one. Again, we've got an x to the invisible 1, or just say an extra x, with 3 of them here. Grand total of x to the 4th. Again, just a lazy way of writing repeat x's. Next one over here, I've got 2 x's, and that becomes our exponent. Remember, invisible 1, so if you want to technically add the exponents, you can, but most people just say, I've got 2 x's. That's your exponent. And again, y squared. And last but not least, if you guys haven't figured out, we can rearrange this to look like y squared, y to the third, and x to the third if you want to put your y's together. Or any order you want. Commutative property, change order. The bottom line is, if we put these y's together, or these y's together, we've got 3 and 2 for a total of 5 y's. And again, you can write that in reverse order, which is actually the way most of the math geeks like it, alphabetical. In either case, that's our exponents rules. It's nothing new. Let's go to example 4. I'm going to expand this up a little bit. Okay, bracket off. And let's start with our first bracket. Bracket 1. 2 in the house, so this is a distribute problem. Here we go. We're distributing a negative 5x to the third, so we're going to do our arrows. Now in this example, by the way, they want to try to skip the expanded step and go right to the exponential. So let's see if we can do this. negative sign, 1. 5 times 2 gives us the 10. And now we've got 3 x's here mashed with 3 more x's. Think about that. X to the third and another x to the third, add exponents, x to the 6. Next arrow. 2 negatives creates the positive. 5 times 4 gives me the 20. And now we're mashing again. X to the third and another 2 more x's. X to the 5th. So that's skipping where we throw all the stuff into a pile. We're literally going to just do it in one step. Alright, next step, or next bracket. 1 in each house, so this is a straight up mash. 1 negative sign makes the whole thing negative. Mash the numbers, 2 times 5 is 10. And here we go. I've got an x here. I'll put the invisible one even though most of you guys don't. Another x here, and another x here. For a grand total of exponents added together 3. Last bracket, 1 in each of the house, so it is a mash. Count the number of negatives. 2 negatives creates a positive. Mash the numbers, 5 times 4, another 20. And now again, this is where you got to be careful. We've got y's and x's. If we start with the y's just because it's first, y to the 4th, and an extra y, you can put the 1 there, of course gives us y to the 5th. There's no more x's, so we got to throw it into the pile under mash rules. And again, you can reverse this if you want. And that is how you guys do exponents. Don't overthink it. It's nothing more than mash rules. Again, mash, M for multiply everything. You guys know that. Signs in your head, multiply the numbers. The only additional thing is this word A in mash, right there, which gives us the add exponents. Nothing changes. You are officially ready to handle exponents.